A supermarket employee wants to construct an open-top box from a 14 by 30-inch piece of cardboard. So that was me trying to draw a rectangle. Let's try it one more time. There we are. Not bad. So we'll call you 30. We'll call you 14. That is sentence number 1. Sentence number 2. To do this, the employee plans to cut out squares of equal sides from the 4 corners of the 4 sides and bend it upwards. All right, so we're starting to get a picture here. Here's a square. We'll call you X. Here's a square. We'll call you X. Here's a square. We'll call you X. Here's a square, we'll call you X. So each sides here of the square are called X's. Lots of X's, kind of like me and my dating history. Hey-o! It's not true. What size should the squares be in order to create a box with the largest possible volume? So let's try to visualize what's going on here. All right, after we cut out these X's, let me try to draw a picture that looks like that. Not bad. Can I make it smaller? Yeah. All right. That's the best I can do. Let's move that over. Let's do that. Oh, not bad. Let's do that. Let's do that. Not bad again. And let's do that. And let's do that. I'll take it. So what's going to happen is we're going to take that and we're going to bend these upward. Bend them up, bend them up, bend them up. When you bend them up, you have yourselves a cardboard box without a top to it. Okay, cardboard box without a top to it. That's me attempting to draw a cardboard box. It looks awful. But there you have it. Now, I have to figure out what these measure up to. Well, if I were to fold that up and pretend that this is that, this side length is not 14. It's 14 minus x because I cut out 2 of the sides there. Again, when I bend that up, this is that. This little length is that. And so that length is 14 minus x, so 14 minus 2x. Similarly, this whole thing was 30. But after I bend these up to create that length, it's 30 minus 2x. And then I have the height. Since I bend it up, it's going to be the size of the squares that I cut out, x. My job is to maximize the volume. So we need to write ourselves a volume formula. So volume is normally length times width times height. In this case, our volume is going to be that times that times that. So we have x times 30 minus 2x times 14 minus 2x. So it doesn't really matter. We're going to have to multiply things anyway. So let me distribute that x. I have x squared in parentheses, just kidding, 30x minus 2x squared. I don't know why I jumped out to x squared. But we have 30x, x times negative 2x is negative 2x squared. And then we're going to FOIL that out to 14 minus 2x. All right, so 30 times 14, that's 420. So we've got ourselves 420x. 30x times negative 2x is minus 60x squared. Negative 2x squared times 14 is going to be minus 28x squared. And then 2x squared, negative 2x squared, and negative 2, positive 4x to the third. Let's combine like terms, put this all in standard form. We've got ourselves 4x cubed, negative 88x squared, and positive 420x. Now, I found my volume formula, and there it is. If I'm going to maximize it, I need to take the derivative and find critical points. This is very, very, very similar to when you do extrema, maxes and mins. But I'm going to add a little extra thing to it. It's not just relative extrema. I have to go one step further. Before I even do any of that, I got to get critical points. So V prime is going to equal 12x squared. Let's multiply that minus 176x plus 420. get rid of the x and stop making so many typos and writing errors. Now, in order to do critical points, I have to set it equal to 0, and I'm going to factor the 12 out because I think I can. Oh, I can't factor out a 12. Well, this is frustrating. Let me see. I can factor out a... Can I factor out a 6? No, I can't, but I can factor out a 4. If I do that, that leaves me with 3x squared minus, what is that, 44x plus 105. All right, I could use, whatchamacallit if I wanted to. Quadratic formula, but give me 1 second. Oh, you know what? That's 35 and 3. 35 and 3. Ooh, 3x minus 35 and x minus 3. All right. I'm going somewhere. So my critical points so far are going to be, if I set these each equal to 0, okay, first off, 4 means nothing. If I set that equal to 0, one of my critical points is 3. If I add 35 and divide by 3, that gets me 10 and 2/3, I believe. No, 11 and 2/3. But since this is a maximization problem, I'm bound by real life endpoints. So this is more like the absolute maximum and minimum where I have an interval to deal with. If I'm cutting x's out, I can't cut any more than 7. So I have legitimate endpoints of 0 because I can't, have 0 squares to cut out. And I can't go further than 7. If I were to try to cut out x's, if I were to try to make 8 my x, that's too much to cut out. So 7 is one of my endpoints and 0 is one of my endpoints. But since I found out that 7 is an endpoint, you can't work. So what I'm going to do is I'm going to find the volume using this formula right here by plugging in 0, which I know will not work, 7, which I know will not work, and 3, which is going to have to work. So let's do it anyway. Volume of 0 is going to be blah, 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 0 cubed minus blah, blah, blah times 0 times plus blah, 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 0. So I get 0. So that makes sense. If I can't fold it up, I get 0. Now let's try 7. If I plug in 7, the original volume problem gave me that. So 14 minus 2x. So what's going to happen is this part is going to become 14 minus 14. So let's just make believe that you understand what I'm doing. If I were to plug in 7, I'm going to get 0 again. So 3's got to be my only guy. So let's plug in 3. 4 times 3 cubed minus 88 times 3 squared plus 420 times 3. It's going to give me some number. And what it's asking me here is you don't have to find that number. Just find out the sizes of the squares in order to make it work. Well, 3 is going to be my guy. So 3 inches is going to be my answer. So maximization problems, optimization problems are pretty brutal, this being one of them. But, after all of that work, I think we finally figured that out. It's not going to be the prettiest answer, but it'll do.